Hey, hi, how are you? In today's class, we'll be doing speed, distance, and time, the practice video. I'll request all of you to pause the video for 2 or 3 minutes, try solving the question yourself, and then check the answer with the solutions provided. So, let's start today's class. So, in the first question, while going 4/5 of speed, a man reaches his destination 25 minutes late. Find the initial time taken by the man to cover the same journey. So, we already know this formula. Time equals to distance by speed, right? So let's say the original speed of the man be s kilometers per hour. Let the original distance, means the distance is the same, distance is d kilometers. Therefore, time taken, let's say t, will be distance by speed hours, right? This is the first case. Now, when he's traveling at 4/5 of the speed, he is reaching 25 minutes late. Let t2 be the time taken when speed equals to 4/5 of s, right? Distance will be the same, distance equals to d kilometers. Now it is given in the question the difference of t2 and t is 25 minutes, right? He's 25 minutes late, so he's taking 25 more minutes in t2. So t2 minus t will be 25 minutes. Or since we have assumed in kilometer per hour, we have to convert the minutes into hours. Or T2 minus T equals to 25 by 60 hours. Or we can write T2 as distance by speed. So distance will be D and speed will be 4 by 5s, right? And T will be D by S equals to 25 by 60. Or D by S, if we take common, we get 5 by 4 minus 1 equals to 5 by 12. Or d by s equals to 5 by 12 into 4. Or d by s equals to 5 by 3. D by s is nothing but t, which is the original time taken, right? So our t will be 5 by 3 hours. Super easy sum. I hope everyone have got this sum correct. So let's proceed to the next question. Okay, so this is a circular motion question. So we have three runners A, B, and C who started running on a circular track such that A and B have started in the same direction while C starts in the opposite direction. The time taken to cover one lap by A, B, and C are given. Find the time taken when all of them meet for the first time if all three have started from the same point. Okay. So let's say this is a circular track, right? And let's say this is the starting point of A, B, and C. A is taking 25 seconds, B is taking 40 seconds, and C is taking 50 seconds, right? Now we are given that A and B have started running in the same direction, right? So we know that in a circular track, when two people start running in the same direction, the time taken when they will be meeting for the first time will be xy by x minus y. So here A and B will be meeting for the first time in xy by x minus y, or x and y will be the time taken to cover one lap. X and y will be 25 into 40 divided by 40 minus 25, or this will be 1000 divided by 15, or it will be 200 by 3 seconds. So A and B will meet each other after 200 by 3 seconds for the first time, and this cycle will repeat. After every 200 by 3 seconds they will be meeting each other. Now it is given that C is moving in the opposite direction. So we can compare C with either A or B. So let's say we are comparing with A. You can do this with B, the answer will come same. The final answer, I mean. So A and C are moving in opposite direction. So the time taken when A and C will meet each other for the first time will be xy by x plus y. So this will be xy by x plus y. This is 25 into 50 divided by 25 plus 50. This is 25 into 50 divided by 75, or this is 50 by 3 seconds. So A and C will meet each other after every 50 by 3 seconds. Now to find out when A, B and C, these three people will meet for the first time will be LCM of the time taken by A and B in one side and A and C on the other side. So our final answer will be A, B and C will meet each other will be nothing but LCM of A and B, which is 200 by 3, and A and C, which is 50 by 3. When we'll be doing the number system chapter, we will learn there that LCM of two fractions, let's say A by B and C by D, will be LCM of the numerators divided by HCF of denominators. Right? So similarly, applying the same concept here, we are getting LCM of the numerator, which is 200, 50, divided by HCF of denominators, which is 3, 3. So the LCM of 250 is 200. The HCF of 3, 3 is 3. So the answer comes 200 by 3 seconds. So A, B and C will be meeting for the first time after 200 by 3 seconds. Clear? Okay. So in this question, we are given that the average speed of a train between two stations is 96 miles per hour without stoppages and 84 miles per hour with stoppages. How many minutes per hour on an average were the stoppages? Okay. So this question is very simple based on a simple idea of wastage of time. So we are given that speed without stoppages equals to 96 miles per hour, right? And speed with stoppages equals to 84 miles per hour, right? So on an average, I am losing 12 miles per hour due to stoppages, right? So if my original speed is 96, so for every 96 miles covered in 1 hour, I am losing 12 miles, or my wastage I can say is 1/8 of my original speed. So the wastages per hour will be 1 by 8 into 60 minutes, which translates to 7.5 minutes per hour. So I am losing 7.5 minutes due to wastages per hour. Super easy sum. Let's move on to the next question. In a flat race, x beats y by 30 meters and z by 58 meters. When y and z run over the same track together, y wins by 30 meters. What is the length of the track? Okay, so in this question, we will be using the concept of the proportionate theorem for distance and speed, right? If you will remember, let's say two people A and B, A is traveling 1 kilometers and B is traveling 1.5 kilometers in say 1 minute, then in 2 minutes, assuming that the speeds of A and B are constant, A will be traveling 2 kilometers and B will be traveling 3 kilometers. In this, you will find that the ratio of the speeds of A 1 by 2 is the same of the ratio of the sorry, cut. In this, you will find that the ratio of the distance traveled by A, which is 1 by 2, is the same as the ratio of the distance traveled by B, which is 1.5 by 3, since the speeds are constant, right? So in this sum, we can do a similar logic. So x, y, and z, right? Let's say the length of the track is x meters. In the first race, x has beaten y and z. So x has already traveled the x meters. So we'll write here x under x's column. In y, since y has been beaten by 30 meters, so by the time x has traveled x meters, y will be traveling x minus 30 meters, right? And z would have traveled x minus 58 meters, right? Super clear. Now, on the same track, when y and z were running, y has beaten z by 30 meters. So when y has traveled the same length x meters, which is the total length of the track, then in that case, z would have traveled x minus 30 meters. So using the proportionality theorem, we can say x minus 30 by x equals to x minus 58 by x minus 30, right? Or x minus 30 whole square equals to x into x minus 58, cross multiplying them. Here we get x square minus 900 plus 900 minus 60x equals to x square minus 58x. We are cancelling x square on both sides. Or 2x equals to 900 or x equals to 450. So the length of the track is 450 meters. So let's move on to the next question. So in this question, A and B start from the opposite ends P and Q of a swimming pool. They meet at 14 meters from P for the first time and 2 meters from Q for the second time. What is the length of the pool if both swimmers swim at constant but different speed? Please don't get confused or frightened after seeing this last line. If both swimmers swim at constant but different speeds, this is nothing but it said that the speeds of A and B are not the same and they are moving at a constant speed. That's it, right? So let's say this is the pool, right? So here is the one end P and here is the other end Q. A is standing here and B is standing here. Now they have started swimming. For the first time, let's say they are meeting at this point, which is 14 meters from P. So let's say length of PQ, which is the length of the pool, be x meters, right? So in the first meet, A will have covered 14 meters, right? And B would have covered x minus 14 meters. Since the total length is x, so when A has traveled 14 meters, B would have traveled the remaining length x minus 14 meters, right? So let's also side by side write the distance traveled. In the first meet, A has traveled 14 meters and B has traveled x minus 14 meters. Clear? Now, in the second meet, when A has reached at this common meeting point, he would have swum here and then again take a U-turn. And let's say he reaches at this point. And similarly, when B was meeting A at this point, B would have swum like this and then would have met again A at this point. So if we'll see what's it's given that this length, the small length is given as 2 meters from Q. So the remaining this length will be x minus 2 meters, right? So A in the second leg would have covered this distance and this distance, which is x minus 14 plus 2 meters, which equals to x minus 12 meters. B, on the other hand, would have covered this 14 meters leg and this x minus 2 meters leg, which becomes 14 plus x minus 2. This equals to x plus 12 meters. Now, using the constant speeds information given in the question, we will use the proportionality theorem. So, 14 divided by x minus 12 equals to x minus 14 divided by x plus 12, right? This becomes 14x plus 168 equals to x square minus 26x plus 168. We are cancelling 168 on both sides. This implies that x square minus 40x equals to 0, or x common, x minus 40 equals to 0, or x equals to 0 or 40. But x cannot be 0 since the length of the pool cannot be 0. So the length of the pool is 40 meters. Right? A very fairly simple sum. Let's move on to the next question. Okay, so in this question, we are given a boat speed in upstream and the boat speed in downstream. Find the speed of the boat in still water. Some of you might get confused, but remember the concept video. The first point जो मैंने बताया था कि whenever we are trying to find out the speed, it is total distance divided by total time taken. So मैंने आपको ये भी बताया था कि in boats वाला question you have always to find what's मेरा upstream का speed and what's मेरा downstream का speed. So here the upstream speed or the relative speed in upstream will be total distance, which is 30 kilometers, divided by total time taken, which comes to 5 kilometers per hour, right? Downstream में speed is total distance traveled is 34 kilometers, total time taken is 4 hours, which translates to 8.5 kilometers per hour. Now let's say the speed of boat be SB and the speed of stream be SS. So SB is my speed of boat and SS is my speed of stream, right? Now we know when a boat goes upstream, the relative speed will be speed of boat minus speed of stream. And when a boat goes downstream, it gets the speed of the stream as well. So the relative speed will be speed of boat plus speed of stream. So we can write that speed of boat plus speed of stream equals to 8.5 and speed of boat minus speed of stream equals to 5. So adding these two equations, we get 2 into speed of boat equals to 13.5 or speed of boat equals to 6.75 kilometers per hour. So the speed of boat in still water is 6.75 kilometers per hour, right? Let's move on to the next question. Okay, so a train's journey is disrupted due to an accident in its track after it traveled 30 kilometers. Its speed then comes down to 4/5 of its original speed and consequently it runs 45 minutes late. Had the accident taken place 18 kilometers farther away, it would have been 36 minutes late. Find the original speed of the train. This is a very interesting sum, so let's start. So let's say this is the track and the accident took place here. So this distance mentioned has been mentioned as 30 kilometers. Let original speed be s kilometers per hour, right? So here the train has traveled at the speed of s, and after this accident, the speed of the train is 4/5 of the speed, which is 0.8 s, right? Now, in the second case, it is given that let's say this is again the track and the accident took place 18 kilometers further from the first spot. So let's say this is the first spot and this is the second spot. So this distance is 18 kilometers, right? So if the accident took place 18 kilometers farther away, it would have been 36 minutes late. Now to solve this sum in a very simple manner, let's split this entire scenario into three parts. This is part 1, this is part 2, and this is part 3. Now let's go one by one. In part 1, this 30 kilometers leg, in case 1, this is case 1 and this is case 2. In case 1, the distance is 30 kilometers, the speed is s, and as well as in case 2, the distance is 30 kilometers and the speed is also s, so no difference. Now let's come to part 3. Here, whatever the distance is, the speed is 0.8 s. Similarly, in case 2, the distance is the same and the speed is also 0.8 s. So, part 1 and part 3 are same in both cases, right? So, in case 1, when the train is late by 45 minutes and in case 2, when the train is late by 36 minutes, the net difference in the time taken, which is 9 minutes, is accounted for by part 2. Now let's come to part 2. The distance in part 2 is 18 kilometers. The speed of part 2 in first case will be 0.8 s, since the accident has already taken place here, right? And the speed in case 2 will be s, because the accident has not yet taken place, it is taking place at here. So the time taken in case 1, time taken in case 1 will be distance by speed, which is nothing but 18 kilometers divided by 0.8 s, and time taken in case 2 will be distance by speed, which is nothing but 18 by s. Now time taken in case 1 and the time taken in case 2 accounts for the 9 minutes difference. So 9 by 60 equals to time of case 1 minus time of case 2, which is 18 divided by 0.8 s minus 18 divided by s. If we simplify this, we get 3 by 20 equals to 18 by s. If we take common, we get 0.2 divided by 0.8. This is nothing but 18 by s into 1 by 4 equals to 3 by 20. 4 and 20 cancels, is 5, or s equals to 30 kilometers per hour. Okay, so the next question. A cyclist and a bus starts from cities P and Q respectively at the same point of time. They meet at a roadside dhaba. One day the cyclist started 42 minutes late. As a result, they met at a point 5 kilometers away from the dhaba. Find the speed of the bus if speed of the cyclist is 10 kilometers per hour. I want you to remember this small concept which we have done in the concept video, which is, let's say this is a track. Here two people A and B are moving towards each other. They are meeting at say this point T. A has covered say 5 kilometers. B has covered say 10 kilometers. So the ratio of distance covered will be the same of ratio of speed, which is equals to 5 is to 10 or 1 is to 2. However, the ratio of time taken will be inverse. If you remember x is to y, time will be y is to x. So the ratio of time in this case will be 2 is to 1. We will use a very similar logic in this question. So let's start. Okay. So let's say this is the road in, and here is city P and here is city Q. Cyclist starts from city P and the bus starts from city Q. The speed of the cyclist is given as 10 kilometers per hour. Let's say at this point the roadside dhaba is situated. Now let's say when the cyclist has started 42 minutes late, uh, the bus is moving at its own usual time. So let's say when the bus has reached at this dhaba at its usual time, and the cyclist will be somewhere say, let's say here the cyclist has reached here since he's arriving late. So we can say that had the cyclist been running at its own normal time, cyclist would also have reached dhaba. So to cover this distance, cyclist takes 42 minutes. We can say that fairly simple. Now, the distance covered in 42 minutes by the cyclist equals to 42 by 60 into 10, which is 7 kilometers. So we know that this distance is 7 kilometers. One more information we are given that they have met at a point of 5 kilometers away from the dhaba. So the meeting point of them will be here, which is 5 kilometers from the dhaba. So the bus has traveled 5 kilometers from dhaba and cyclist would have traveled the remaining 2 kilometers, right? Since the total is 7 kilometers. So let's draw again this meeting point. Here is the dhaba and here was the cyclist. They are meeting say at this point. This is 5 kilometers. This is 2 kilometers. And cyclist speed is 10 kilometer per hour. So ratio of distance equals to 2:5 for the cyclist is to bus, right? And uh, the ratio of speed will be same, 2:5 for the cyclist is to bus. Now, if speed of cyclist is 10 km per hour, therefore speed of bus will be 5 by 2 into 10, which is nothing but 25 km per hour, right? A very interesting question. I hope most of you have got it right. Now, let's move on to the next question. Okay, so in this question, Mr. X takes 52 steps to walk down an escalator, and this takes him 1 minute. Now he runs down an escalator in 36 seconds and he covers 68 steps in this process. How many steps are there in this escalator? So this is an escalator based question. Let's start. Let the number of steps in the escalator be n. Also, let's assume speed of escalator be x steps per second. So in this type of question, we have always, whenever the person is moving down or up, he has to cover the entire number of steps, which is n, whether he is running or he is walking down. Now, there are two cases here. In case 1, the man, Mr. X, has traveled 52 steps on his own, and the escalator has also helped him by moving 1 minute. So, in 1 minute, the number of steps that the escalator has taken is 60 into x. So, this total 52 plus 60x is nothing but n steps. Now, in the second case, when the man is running down in 36 seconds, so by himself, he is traveling 68 steps, and in those 36 seconds, the escalator has helped him to cover 36x steps, which again totals to n steps. So, we can equate these two equations and get 52 plus 60x equals to 68 plus 36x. This implies that 24x equals to 16 or x equals to 2 by 3 step per second, right? Now we are required to find how many steps are there in the escalator. So n can be computed either by these two equations. Just put the value of x. So let's say in equation 1, n equals to 52 plus 60 into 2 by 3. This equals to 52 plus 40. This equals to 92 steps in total. So you can use this concept in whenever you find an escalator based problem. Next question. So this question came in CAT 2023, a very simple question. So let's start. In this question, people will usually make mistake in units or in calculation. Otherwise, it's a very easy sum. Now let's start. Ravi is driving at a speed of 40 kilometers per hour on a road. Vijay is 54 meters behind Ravi and driving in the same direction as Ravi. Okay, so Ravi and Vijay are driving in the same direction, and Vijay is behind Ravi. Okay, Ashok is driving along the same road from the opposite direction at a speed of 50 kilometers per hour and is 225 meters away from Ravi. The speed in kilometer per hour at which Vijay should drive so that all the three cross each other at the same time is okay. So let's say this is the path. Here is say Ravi, who is traveling at a speed of 40 kilometers per hour, right? Here is say Vijay, whose speed we have to find out, and he is 54 meters behind Ravi. So in order to ease this problem, we have to convert everything in either kilometers or in meters. So let's say we are dealing in only kilometers and hours. So 54 meters comes to 0.054 kilometers. Now it is given that Ashok is driving along the same road from the opposite direction. Let's say Ashok is here, he's driving in the opposite direction, and Ravi and Vijay are driving in the same direction. Ashok का speed दिया हुआ है. Ashok is traveling at 50 kilometers per hour, right? And the distance between Ashok and Ravi is given as 225 meters or 0.225 kilometers. So we know that when two objects are moving towards each other, the time taken when they will be meeting for the first time will be distance by total speed. Total speed is, the relative speed is 40 plus 50. So here time taken for Ravi and Ashok to meet each other will be distance 0.225 kilometers divided by relative speed. Relative speed will be 40 plus 50 kilometers per hour. Right? This comes to 0.225 divided by 90. This comes to 0.0025 hours. Right? So when Ravi and Ashok will cross each other, they will be not meeting again because the question has not said that they will be coming back and meeting for the second time, nothing like that. So they will meet for only one time. Now Vijay has to reach also at 0.0025 hours in order so that all three are meeting each other at the same point of time. So for Vijay, time taken will be the same as 0.0025 hour. Also, let's assume that Ravi and Ashok are meeting at this point. So Ravi has to travel at the speed of 40 km per hour for 0.0025 hour to meet Ashok. So this distance, Ravi's distance will be 40 into 0.0025 hour. This is kilometer per hour. This comes to around 0.1 kilometers. So this distance is 0.1 kilometers. So Vijay in total has to travel a distance of 0.054 plus 0.1 kilometers. This comes to 0.154 kilometers. Therefore, speed of Vijay will be distance by time taken, which is nothing but 0.154 divided by 0.0025. This comes to 61.6 kilometer per hour. Right. A fairly easy sum. Let's move on to the last question. Okay. So this is a famous gunshot problem. Let's try to solve this. X fired two bullets from the same place at an interval of 12 minutes, but Y, who is sitting in a train, is approaching the place. Here's the second report 11 minutes 30 seconds after the first. Okay. Find the speed of the train if sound travels at a speed of 330 meters per second. Okay. So let's say X is here. He has a gun. Apologies for the drawing. So Y, let's say is at this point A, who is traveling in a train. Mr. Y. Yeah. So when the first gunshot was fired, the immediately second gunshot was fired at an interval of 12 minutes. But why he is moving? Let's say he has moved from point A to point B. And here's the second report after 11 minutes 30 seconds. So let's say when the sound has traveled at point B, we can easily say that sound is taking 12 minus 11.5 minutes to reach from B to A, which is nothing but 30 seconds. Had Mr. Y stayed at point A, he would have heard the sound exactly after 12 minutes. But since Mr. Y is moving, he is having a delay of 30 seconds. This delay of 30 seconds is the exact time which the sound is taking to move from point B to point A. Super clear? Also, for determining the speed of the train, we can also say that for the train to move from point A to B, it is taking 11 minutes 30 seconds, right? So train is taking to cover point A to point B in 11 minutes 30 seconds, right? The distance traveled by the sound will be the same as distance traveled by the train, which is equals to AB. Correct. Now डिस्टेंस का फॉर्मूला क्या था? डिस्टेंस इक्वल्स टू स्पीड इनटू टाइम. डिस्टेंस ऑफ साउंड will be speed of sound into time taken by sound equals to speed of train into time taken by train, right? So speed of sound is given as 330 meters per second. Time taken by sound is 30 seconds. Speed of train is not given. We have to find out speed of train, and time taken of train to cover the journey is 690 seconds. So speed of train equals to 330 into 30 divided by 690. Simplifying it, we get 330 by 23 meters per second. So this is the speed of train, right? I hope you liked today's class. So please like, share and subscribe my channel and have a great day ahead. Bye.